So, so by getting this, here's my ratio, and then let's see how they look at it, okay? So there's a few different ways that we can think about this, all right? So first of all, we can think about it for every 2 cups, I need this much. For every cup of milk, you could do a division and say, I need a certain amount for every cup, right? I could divide 5/4 by 2, and that's how much I need per cup. And, then you can figure that that way. Now, so that's one way you can do it. Now, personally, I think the easiest way is to basically do a proportion, right? Remember working on those first semester? And I do my butterfly, right? Remember working on the butterflies first semester? Hold on a sec, I gotta check Angelina. So that's the easiest way. But then, so they're talking about breaking it down all these ways. But I don't think you really need to do all this kind of work, because in my mind, you already have a reasonable path to the final answer here, don't you? If I need 8 of this, and I can see an easy way to convert from 2 cups to 8 cups, why would I go through all this crazy rigmarole of doing all this fraction division and all that when I can just intelligently skip right to the end by doing it by 4? Now, here's the deal. Multi-step problems are only multi-step if you don't know a simpler solution, right? Or a more elegant solution, as the case may be. So when we do something like this, we find a way to basically find the path around, right? And basically we did the same thing, right? Because we just did the same stuff, because we multiplied by 1/2 times 8. How much is that? 4, right? Because half times 8 is 4, right? Well, we just did that one step, didn't we? So yeah. Okay. Does that make sense? Do you see how we did that? Okay. Now let's take a look at this one. Gas prices are projected to increase by 115% by the end of next year. Gas currently costs. What is the projected cost per gallon of gas by May 2013? So now, if we look at this, we're going to assume this is at the beginning of the year, okay? And it's going to go up by 115 by the end of the next year. A gallon of gas currently costs $2.50. What's the projected cost of gasoline in May? So what do we know about what the price of gas might be approximately in May? Well, it's not going to be 115%, right? It's going to be some portion less than that, right? Does that make sense? If you're assuming that something's going to grow by 115% over the course of a whole year, this is 5 months, right? Do we see that? So really, we're looking for 5/12 of this growth. Does that make sense? Do you see how that works? Because we're talking about it as being like a graph, right? That because we can't see individually and we're doing projections, then we're basically looking at it like a graph that says, okay, well, it starts here at 250, and up here it's going to be 250 plus 115%. And what we want is somewhere about here, which is May, and we don't know what that value is. You remember when we did some of those approximations of square roots? Remember when we did those? Did we do that in this? We did that this year, didn't we? When we did those approximations where we like used a fraction, did we do square roots here? Sometimes my years all stream together, I'm afraid. So this is what we're going to do. We can do this as one big problem, right? So this will be the amount of increase. Let's look at this and see if this makes sense. 5/12 takes into account the amount of time during the year that has passed, right? May being the 5th month, we're going to get 5/12 of the growth that we would get the next year. Here's the growth that's projected for the entire year. So now I'm getting my fraction or my percent or whatever, however you want to say it, of growth. And then I finally multiply it by the price that existed originally. So this is just going to show me, growth. Do you see that? Does that make sense how we do that, folks? So if I tell you that if I tell you that this is going to grow by like $3 over the course of a year, and it's going to be $5.50 up here, then I could take $5.50, right? I could subtract 250 from it, and then I'd find out what the growth was. But if I wanted to find out how much it changed by May, I'd multiply it by that 5/12 to find out how much it grew by May, approximately. So let's take a look at this, and we'll look at it a couple of different ways.
Mr. Easley,
Yep,
how did you get 115 over 100?
because it's 115%. So if you're going to express 115%, 115%, right? Remember that any percentage can be expressed by being put over 100 to express as a fraction, right? Okay. So I can multiply all this craziness out. I'll get some amount of growth. And then I'm going to add that to 250. Now, I don't even care if we're solving this, frankly, because it doesn't matter to me. Okay. Now let's see how they do it. I always find it fascinating how other mathematicians think. It's one of the things about math that's most fascinating to me, because everyone approaches math in a completely different way. We've talked a lot about that, haven't we? How everyone thinks of math and comes at it from a different perspective. We have different strengths in our math skills, and so we tend to favor those strengths because they've always worked for us, right? So let's see how they do it. The original cost of a gallon of gas is $2.50. An increase of 100 means that the cost will double. So here they've put the 100% here, right? Another 15% will need to be added to figure out the final projected cost of a gallon of gas. Now, here's the thing that I don't agree with. Now, they're acting like this is for a full year, right? But that's not what they said here, was it? Did they say anything about May 2013 being the final, the end of that, being the end of some year of progress? So this is where I have an issue with this word problem, right? Now, if they had told us that it's currently May, besides they said by the end of the next year, well, May 2013 isn't the end of a year, right? So I'd like to argue that my interpretation of that question is probably more accurate based on the information we have. What do you think? Now you can disagree if you're like, nah, you're crazy, Mr. Easley. I don't see that. But I don't see how we can just simply give it a 15%. Do you? 115%? Because that's making the assumption that May 2013 is going to be the end of that year. Now, if they had said by the end of 2013, okay. But can you see how they worked it out? They kind of thought of it a different way, right? Now, I mean, I realize it was my solution, so obviously I'm a little more happy with my solution, right? But I'd like to point out that when we do more complicated problems, we have to think beyond just straight numbers. We have to reason stuff out. So we call in school, we call in teaching profession, we call that higher level thinking, right? The idea of going beyond simply doing math, but then being able to analyze what's going on and figure it out. Now, I would say that this is how we should do it. So if it starts at 250 and at the end of the year it's plus 115%, then I think how we did it made sense, right? Because 5 over 12 represents how much growth would have occurred between the beginning of the year and by the end of May. Yeah? Does that make sense to you guys? Do you see that as like finding a percentage of the annual growth? And we're just expressing it as a fraction because at this point, it's easier than trying to convert 5/12 to a percent, right? So sometimes fractions are going to be your friends with some of these problems. How many people hate fractions? How many people hate fractions? Can, can you see with this problem how a fraction can really be your friend though? Because using it as a ratio, it can make the calculation simpler. Because basically I'm going to do 5 times 115 times $2.50, and I'm going to divide it by 1200, right? I mean, that's really what you're doing there. And I don't think that's hard to figure out. So basically, instead of doing 5/12 as being like some kind of magic fraction, it's just there to show me like a percentage of this total growth over this entire arc, right? So then that'll give me my growth. Let's calculate it out because these boogers, I don't like their solution. But I don't mind their solution because guess what it helps us to have? It helps us to have a different way of viewing it and seeing that there are multiple ways to do it. How many of you enjoy seeing multiple ways of a problem being solved? Do you guys like that? Is that helpful to you guys? It's always helpful to me because I feel like it helps me find the best way that I can solve something. All right, now let's do our multiplication. So there's my 5 times 115 times 2.5, right? And I'm going to divide all that by 1200. And I get $1 and 20 cents, right? Because I'm going to round it. See how that 7 is going to make me round that to 20 cents? Okay, because that 7 says bump up the 9. When I bump up the 9, it's going to bump up the 1, right? So it's going to increase by $1.20 by May. So that means in May, the price will be $3.70. What do you think? Yeah? Do you think you're better at doing word problems now? I bet you are. I bet you're a lot better at them. Okay, let's look at this one. Okay, let's look at this. Clark's weight is increasing these days. This must take place during the pandemic, right? He's sitting home all day and eating like I am. Swear to God, I've put on so much weight this last year, it's pathetic. Clark's weight is increasing these days. If his weight increases by 2 kg per 4 months, how many kilograms will he gain after 16 months? You might want to turn off your TV there, Brandon. It's telling stories on you. So how do you want to try to solve this, Aaliyah?
I'm not sure. I'm still not that great at word problems. But why did they have to use my last name for an increasing weight problem?
Actually, Clark is a first name sometimes, So they're not saying Aaliyah Clark. They're saying some guy named Clark, like Clark Kent, that kind of name. So if he's growing by 2 kilograms for every 4 months, how much is he going to grow in 16? You can send it to me in the chat if you like. Tell me what you think. I'd like to see a bunch of people tell me what they think the answer is going to be. Look at it and see if you can calculate it for me. Well, those are all good guesses so far, but we need to think about what's changing. There you go, Camden. That's my guy. Yeah, baby. Right, Mary, good job. So let's take a look at this again from good, Julie. Thank you. Let's look at it like uh, a proportion. I have kilograms and months. So what am I going to do over here? Which one is unknown and which one do I know?
We know the 16 months.
And where should the 16 go in this other ratio?
For the denominator.
Right. And then this is going to be X, which is our unknown, right? So I do my butterfly wings and I'll get 32 equals 4X. So I'm going to divide both sides by 4 and I get, so in 16 months, he will have gained 8 kilograms. And so the direct relationship is from 4 to 16, right? So if I multiply 4 by 4, I get 16, but then I have to multiply the kilograms by the same multiple. So if this is times 4, then I also have to do it times 4 up here, right? Yeah? Okay. Now, a microwave's temperature increases by 25 degrees every 2 minutes. Well, I'm getting pretty good at these word problems, so I'm going to start writing down numbers if I think I can find something that's not too hard to figure out and write down.
We can't see it.
Sorry. What would be its temperature increase after 5 minutes? So then it says after 5 minutes. So how am I going to solve this one? If it increased by 25 degrees in 2 minutes, how much will it increase by 5 minutes? How will I calculate this? How will I set up a problem that will allow me to solve this? Aaliyah?
I really hope this makes sense when I say it because it makes sense in my head. I know what to do, but it just sometimes doesn't come out in words. So, there's 2 2s in 5. So you would have 50, and then you would divide 25 by 2, so you get half because it's half of a minute.
Okay. I see what you're doing. So you're saying double this and then take another half?
Yeah.
Okay. So you're suggesting it would be 62.5 degrees.
If that's
That would
after
be if
doing
you
it.
double
Yes.
it and add a half. So, okay. So she's looking at double plus 1/2. Okay. And that's how she reasoned it out. And that's okay because our brains work things out. Does anyone else have a solution? A way of looking at this? How would you figure this out? What did we do on the last one? We set up a proportion, right? So let's set up a proportion here. What proportion could I set up here?
You could do the 25 over 2 minutes, and then you would also have X over the 5 minutes.
Right, that'd be the other way to do it, wouldn't it? So now, and I get 2x equals 125, which if I divide by 2, I'll get x equals 62.5. So what Aaliyah basically did was she looked at the fact that she kind of saw that she saw that ratio in her head of how much 2 was increasing to 5. So she kind of worked out what that multiple was, didn't she? Do you notice how she did that? So she worked out that it was a 2.5 multiple, and then she immediately just applied it to the top. Now, she she didn't state it out as being a proportion, but she saw that ratio that was existing. And she saw, okay, well, there's two 2 minutes and half a 2 minute. So I should do two 25s and half of 25. So that works fine. That's great. And to me, sometimes our math skills are excellent and we can see the reality of a problem. Does that make sense? You guys have done that before where you've seen problems and you're like, well, I don't know how you're going to solve it, but I see what makes sense to me, right? Okay. All right, let's look at this one. Smith. Well, all right then. Smith has a garden. He has 10 flowers in his garden. In the spring season, the number of flowers is expected to increase by 110%. What would be the number of flowers in spring? Now, when something increases by 110%, what does that mean actually when it increases, when it goes up by 110%? What does that mean? Jacoby?
I know it has to at least double.
Exactly.
And then,
Thank you. That's exactly what I was looking for. Yeah, because if it's increasing by 110%, you know it's going to at least double, right? Because if I increase by 100%, I'm doubling it, right? Yes, dear.
I think I know how to solve it, but
Well, let me talk this one through, okay? But it's good. It's cool. Hang. So here again, I've got my initial value that I'm going to keep. And then I want to figure out the amount of increase, right? And then I'll combine them. Does that make sense? So the amount of increase, and I'm going to put it between parentheses so that we can kind of keep it separate in our brain, is going to be 10 times 1.1. Now, why do I do 1.1? Camden?
Because you multiply 110.
Well, why do I put 1.1 here? This is the initial value. So what is 1.1? Allie?
How I looked at it is that you took the 110%, the decimals next to the zero, and you moved it to the left. Twice.
Excellent. Yeah.
And then just got rid of the zero.
Decimal. This is the decimal equivalent of 110%, isn't it? Right? Does that make sense? Okay. So now I've got 10 plus, and 10 times 1.1 is going to be 11, isn't it? Because if I multiply by 10, I basically just moved the decimal point one spot, right? So I'm going to find out that at the end of the spring season, I'm going to have 21 flowers. Does that make sense? I don't think these are really hard. I think these are definitely the kind of problems, especially for my honors class, that if you see them work a few times, you can kind of go, oh yeah, well, that makes sense. Now, we've got these two worksheets. One is this matching thing. So of course they don't have any units over here because you're going to have to deal with that. So you're just going to look at these and then you're going to find your answer and you'll write the answer here. The next time I hand out these worksheets actually convert very nicely into Microsoft Word. So I'm going to, after this assignment, I'm going to convert these to Word docs and then I'll upload the Word docs so you can edit them and then turn them right around. Okay? Okay. So that makes sense, right? So like here, Will sells 35 liters of milk a day. How many liters of milk will be sold when he has to sell 125% more milk per day? Well, you're gonna do what we just did in that last problem, right? You're gonna take 35 plus 35 times 1.25, right? That's the same problem we just did, isn't it? And you're gonna get, it's gonna be something around 70. Boom, there it is. That's one of the other nice things about being an honor student, because your brain usually is working better at math than some of your colleagues. And so you can look at that and go, well, that's going to be a little more than 70 because double would be 70, right? If I went up by 125%, it's going to have to be at least around 70. Well, all these other numbers are way too big except for B. So I probably don't even have to do the calculation, do I? I just need to look at it and go, it's going to be about 70. Oh, there it is. I used to do that all the time when I was doing math, and it would drive my friends crazy. They're like, how can you be done already? I was like, well, I just logically figured out what the answers were, and then I had to calculate the last two. And they're like, I hate you. And it's like, well, okay, but I'm sorry that I figured out how to do the math. I mean, and this worksheet is literally about math making sense. Like, here's one that says 4,500. Well, how many of these could be somewhere around 4,500? It's going to have to be a pretty big one. So you know what I did? I looked right here. Here's 2,000, right? And it increases by 125%. So it's got to be more than 4,000, right? Boom. Do you see how
We
that makes
can't
sense?
see what you're doing at the bottom.
Oh, I'm sorry. Here, the last answer is 4,500. And then if you look at, and so it's like, oh, well, I need to find something that's going to have a big number. So here's 2,000, and I'm more than doubling 2,000. Well, more than double of 2,000 is going to be something over 4,000, right? Well, there's only one answer that looks like it'll fit that. Do I even need to calculate this answer? No, because it makes sense. Do you guys see that? Do you see how that answer makes sense? That's kind of cool, don't you think? Okay. I think these are going to be really easy for you. This one, of course, is just going to be the same old stuff where you're honestly just going to have to look at it and calculate it. But I don't think, so like if you look at this first one, the plant grows rapidly. It grows by 10 centimeters every 2 years. How much taller will the plant be in 5 years? Now, the important thing when you're looking at these is how much taller. So that means they want to know the amount of growth. They don't want you to tell how tall it's going to be at the end. They want you to tell how much it's grown in 5 years, right? Now, this is very similar to that one that we did before, right? Where the one where Aaliyah said, well, it's, you know, you have to increase it by double and a half, right? Well, what's double and a half of 10 centimeters? 25, right? So I don't think you're going to find these to be very hard to do. And there's only 18 total problems, so I don't think it's going to be a big deal. All right. Let me go ahead and close out my, where is it?